So today I'd like to talk about the brake and clutch lever assemblies. This is a very cheap set I bought on Amazon for around 10 or 15 pounds, just for the purpose of this video. So let's start with the mounting. So since this is a set that sold on Amazon, it's going to be sold for various different motorcycles. So consider this is a universal brake levers, brake lever and clutch lever. How it's universal is typically the handlebar is usually around 22 millimeters. It's kind of like a standard sizing. So this should fit almost any motorcycle. This is the clamp part. So this would clamp around the tube here. So we have this long part here, this long spigot, and then we have this nozzle. And then we have this mounting and this plunger. So let's start with the mounting point. So for assemblies like this, we're going to have something pivoting around a point. We usually use something like a shouldered bolt. This gives a smooth surface for that to pivot around. Inside this part would be the first part of the brake lever assembly. This would pivot around this shouldered bolt. Now there's a couple of things we'll have on the brake lever. Notice we have this long part here. Well, that would actually be engaging this limit switch. If that limit switch is engaged, it means that the brake is not being applied, so the tail light is not lit. Once you apply the brake, you depress the limit switch and the tail light will light. When we engage this lever, when we apply force here, we're pushing on this plunger. Now this plunger is essentially connected to a volume of space. So let's say we have the fluid reservoir connected to this hose. We'd have fluid in the reservoir. This fluid passes through this tube into the body here. From this body, it's going to pass through the brake hose. And the brake hose, how does it get to the brake hose? Well, we have this thing called a banjo bolt and a banjo union. Essentially, a hollowed out bolt with some holes on either side at the top, where we have a section of the bolt which is not threaded. So this just acts as a channel for the brake fluid to pass through when we apply the brakes. The brake fluid will pass from this bolt into the eyelet or the union of the brake hose. Essentially has a similar design, so the brake fluid can pass from this through the end of the hose and then to the brake caliper. So it also comes with these washers, and these washers are metal on the outside with a small rubber ring on the inside, and a couple of small O-rings. That's to help keep the brake fluid in the system as a seal. Now, with brake fluid in the system, when we apply force to this plunger, all we're essentially doing is reducing the volume of space in this system, and that should be forcing or pushing, displacing the pistons in the caliper to press against the brake pads, which then presses against the brake disc, because fluids are essentially incompressible. This is why air is a bad thing to have in your system. See, air is a gas and it can be compressed. So when you apply force to this plunger, if there is any air in that system, that air is going to act as a sponge and it's going to absorb an amount of this force, and it's going to reduce the amount of force that's being applied to your brakes, to your brake discs. And that's where the sponginess effect comes from. So that's why we don't want air in our system. Now moving on, we have the clutch lever mounting. Now for this one, typically you're going to have your cable come up and it's going to hook in this part here. And to make sure it stays there, we have this fixing that helps to retain it. But that alone is not enough. We also want to attach it to the lever so that when we pull the lever it actually does something. So this part of the lever fits in here, and then on the underside we have a slot where we put the clutch cable into, we hook it in, and that's going to pull the clutch cable when we pull the lever. Now when we let go of the lever, it's going to pull the lever back up. Now there's something else in here as well. We have this strange part here. Now maybe not in American bikes, but a lot of European bikes have this this other switch. This is another kind of limit switch, and it's for the clutch start engines. So if you have to pull in the clutch in order to start the engine, when we pull the clutch lever in, it presses against the switch. When we let go of the clutch, it depresses. So now we're coming on to the adjustable levers. Look at this. This is a CNC machined part. I think CNC machine parts look quite nice, but they're often just very standard in terms of the shape, very blocky. This isn't bad, but it definitely be nicer. Okay, so for this one we have the pivot point. So we fix the lever here. Then it's loose. So there's two more things we have in this assembly. We have a spring, and that rests against this top flat surface to hold tension in this direction. Then the second part, or the second and third part, is this black tab, which is going to be our lever that we're going to be operating ourselves. And then the part that's hidden underneath is this small metal part with these small teeth, and they get further and further out as you rotate it. So how this actually slots on is actually a slot, not just a round hole, so that helps it retain it and ensures that when you rotate it, it rotates the part beneath as well. So when we have this fixed up here, and I've removed the spring, let's ignore that for now. When we adjust this to position 2, 3, 4, 5, 6, all that's happening is this part underneath is pushing out against this body. Now, I don't really like this this mechanism. I think it's very, it's very basic, very cheap, but there's nothing stopping it from sliding, just changing by mistake. It's just too loose for my liking. It's too unreliable, I think. So when I redesign these, which you'll see coming up soon, I will try and design a new mechanism for this, and then I'll probably 3D print some different variations of handles, potentially some extensions. So the last thing I want to do is talk about this part here. So this, when we look at it, we can see there's some lines around the middle. Now these are casting split lines, or seam lines, meaning that this part is made from a mold. They inject metal, molten metal, and then it solidifies, and then we have a cast part. Now, it's all good making this shape that we're going to cast in this block, but there's a few things that people may not have considered. So this line indicates that the block comes up to this point and it splits here. So as we follow this line round, what we notice is that we come to this point and it disappears. We don't know where the split line is anymore. Well, this part, if we consider two parts of a mold, if they were to fill this space, there is no way to remove this part. You can't lift the top off, right? Let's say you lift the top off and this remains in the bottom part. Now we can't pull it out the bottom part. We'll have to break the tool. So there's something that we call it a movement. So if we imagine this is in a block, we essentially have a pocket that goes through this block, and you can see into this space that we want to be. And we just insert another piece of material that fits this shape. We pour the molten metal in, it fills this space, makes this shape. When we're finished with the process, we remove the movement, allowing us to then separate the mold and take this out. So this movement is something that's used in both in castings and in plastic molding. So now let's just take a quick look to see what that looks like in CAD. So this is a simplified version. Usually any cast or molded parts are going to be cast or molded with a draft angle. That's so that you can pull it out the tool easily without damaging the surface. It's also needed if you have any more interesting textures on that surface. So I've just added in the additional feature, which is this cavity within the part. So when modeling something like this, I would usually model the cavity as a solid and then use the combine feature or something like that to remove it from the existing material. We also want to take into consideration any draft angle that's required, and also if there's any restrictions or limitations on the angle or the direction that the movement is coming into the mold. I'm going to be doing some videos documenting my complete design process for a few different components, and I thought I'd start with the brake levers and clutch levers. Reference material is always one of the first places to start to get a good understanding of the assembly. It's important to note any features that are going to be required or anything that you may have to consider in the manufacturing process, so you can keep all of those things in mind as you start your design, or improve them. Thank you for sticking around, and I'll see you next time.